So, in our last discussion, we touched upon the distinction between data, where we specifically highlighted the spatial and non-spatial data. We also delve upon the concept of metadata, and then we learned features of attribute information types, the qualitative data, and the quantitative data. The qualitative data are representing qualitative attributes, etc. In this discussion, we would focus on data models and spatial representation. Here we will discuss the concepts of data and different kind of models and their types. Just to begin with, data models are broader and large. Data models are conceptual way of understanding the world around us. And the data formats are actual computer structures we use to store and display information digitally. As we are dealing with spatial information, most of these data, or rather all of these data, need to be in digital format, and this way the data models and data formats are very important and critical to store and utilize the spatial information. So spatial information deals with all kinds of spatial issues. The geospatial data is representative of both spatial data and non-spatial data, which is also called as attribute data. For example, to define any spatial object or features like a river, we need to know its location and characteristics. We are well aware that a feature's latitude and longitude may be used to determine its exact position to display spatial position, or the location of the feature or object. The characteristic of a river like name, its length, the speed and direction of flow of water within the river, these information represents the attribute information, which we are calling it as attribute data. So to represent spatial features in spatial information science, we generally use various kinds of data models. There are two types of data models basically. They are namely vector and raster data models. As you are aware that our real world is complex, but it is very interesting as to how this real world complexity can be represented in spatial form, more importantly in digital form. Here the spatially referenced data of real world features are commonly referred to spatial database. The spatial database often mixes with some similarities, and to understand the similarities in complex database of the real world, we generally develop models. In simpler terms, a model is an abstract representation of the real world phenomena in many forms, such as pictorial format or the graphical form. And the process of creating geographic data model is similar to that of data modeling. In general, at least in its broad structure, it can be divided into three different levels of model abstraction, such as conceptual, logical, or physical models. We select different types of models for the purpose of analysis based on the availability of data, which is generated and stored as spatial database. So the data model is the core of spatial information science, which gives a set of constructs for describing and representing selected aspects of the real world phenomena, more importantly in digital format. The data model is basically a conceptual representation of data structures in a database. So data structures, on the other hand, are made up of data objects and relationships between those objects and characteristics that influences as to how the object may be used. The data models defined as how real-world spatial features are represented in a spatial information science. In other words, data models represents a set of rules or guidelines which are used to convert the real-world features into digitally and logically representing the spatial objects. We use multiple models during the representation of the real world. First is reality, which consists of real-world phenomena such as natural or human-made features. Other stages are conceptual, logical, and these are physical models. The concept of tools that are developed to summarize and the description of the database. Data models provide us with a transparent picture of data which helps us in creating an actual database. It shows us the form, the design of the data to its proper implementation of data. For example, the conceptual data model is the process of developing a graphical representation from the real world. It determines what aspects of the real world to include and what aspects of the real world we can exclude from the model, and at what level of detail to the model which is to be represented in each aspect. A conceptual data model just includes the main concepts, I will call them as entities, requires to store information and the relationships that exist between these entities. It is a human-oriented and partially structured. We are familiar with spatial features, which are consisting of discrete features, objects or continuous features, fields. Objects such as road, river, a building, etc. These are examples of discrete features because they can be identified separately in the everyday world. Whereas other features such as altitude, temperature, humidity persist constantly everywhere and are referenced to a continuous features or fields. Symbols are used to depict these spatial features on the map. There are three types of symbols that may be found on a map: point, line, and area. These are referred to as fundamental cartographic symbols. You all know that points have no dimension, lines have one dimension, and areas entity are said to have two dimensions. Now, there can be another type of model which we can call it as three-dimensional model, which indicates the volume also, if we can include this also in our discussion. The point symbol is used to represent small features or objects, such as a bank, a post office, or even a college. There can be many other examples which can be represented by a point in a spatial information. Whereas a line represents a linear feature, such as a road, railway line, power line. These are all examples of a line representation. A set of closed lines, a feature indicated by an area symbol, such as a lake, forest, or administrative borders like Aligarh district, they are representing the area entity. Now, just to give a fair idea of different kind of data models, spatial data models, one is known as a logical data model, which expresses the meaning, context of a conceptual data model and adds to that detail about database structures. A logical data model is the most used data model. It goes beyond the conceptual model. It includes entities, relationships, details on entities, different attributes, and unique ways to identify entities. which we may call it as primary keys. And moreover, establish the relationships between them, which we may call it as external keys. A logical data model contains all the details to define an information domain. So, logical model is the representation of reality in the form of diagrams and lists. It takes an implementation oriented approach, and the logical model describes the data representation and also explains the relationship between the features, which means a topological relationship. Now here it is very important to understand what we mean with topology. The topology is the arrangement of features which shares common geometry. For example, any entity like Delhi, the state of Delhi, shares boundary with Haryana, Rajasthan and Uttar Pradesh. So how all of them, they are arranged in space, that is known as the topology. The spatial features are represented either in raster format, which is an array of grid cells, or in vector format, where individual coordinates to represent point, line and polygon features of the ground, of the earth. So a physical data model is usually derived from a logical data model and presents the actual implementation in spatial information science environment. One big difference between logical and physical data model is that we now need to use table and column names rather than specifying entity and attribute names. The physical models has specific implementation approach. So from a single conceptual data model, we would expect to get a more detailed logical data model, both of them designed to represent the required data structures. From that logical data model, we can then create as many physical data models as we require. So up till now we discussed about the concept of data models that use several stages to handle the spatial data. Now we examine spatial data models which describe the real world phenomena in spatial information environment. So in spatial information science, data models comprises the rules which are essential to define what is in operational spatial information science and also its supporting system. So the geospatial data is numerical representation which analyzes and describes the real world feature in spatial information. The nature of geospatial database is dynamic rather than static and allows a range of functions such as organizing, storing, processing, analyzing, and even visualizing the spatial information. Now, you all are now aware all the features from the real world are represented in spatial information science. The spatial data models as point, line, which you can also call as arcs, and area or the polygon entity. The geospatial data depicts the real world in two basic models, such as object-based model and field-based model. So this diagram shows that geospatial data depicts the real world in two basic models, the object-based model and the field-based model. So the real world features that may be transformed into multiple raster and vector data formats when establishing a spatial database. So the object-based models are used for conceptual structuring of geographic information, particularly in the modeling of real-world objects or entities with a precise and absolute spatial location and extent. They are important for modeling various complex applications. The field-based models treat the spatial information space as a continuous domain. It is used for modeling physical properties which is dependent on its spatial location. Examples of this could be the altitude, the rainfall, or the temperature. Here it is important to understand that in spatial information science, this field concept has been extended to include any physical or non-physical properties of which the magnitude, I mean to say the value, is dependent on its spatial location. These are seen as collection of spatial functions transforming a space partition to an attribute domain. So it is clear now that for object-based model, the object is a spatial feature and has some characteristic like spatial boundary, application relevant, and feature description like various kinds of attribute information. The spatial objects represent discrete features with well-defined or identifiable boundaries. For example, buildings, parks, forest lands, geomorphological boundaries, soil types. These are some examples. In this model, data can be obtained by field surveying methods also. Any kind of field survey method, beginning from chain tapes survey, or a much improved version is theodolite, and in the modern day total station surveying, and also GPS, DGPS survey, etc. Or even the laboratory method using the satellite images, aerial photo interpretation, and on-screen digitizing to bring it in the digital mode. So depending on the nature of the spatial objects, we may represent them as graphical elements of point, line, and polygon or the area entity. Another is field-based model. The field models in spatial information science define a field as a value varying over a subset of geographical space. A geometry bounds this subset. So a field in GIS can be defined as a value varying over a geometry. Here the spatial phenomena are real-world features that differs continuously over space with no specific boundary. Data for spatial phenomena may be organized as fields which are obtained by direct or indirect sources. The source of direct data is from, for example, aerial photos, satellite imageries, and also scanning the hard copy maps or even field investigation, which can be made at selected sample locations. So that way we can obtain or generate the data by using some functions like mathematical functions such as interpolation, sampling, or reclassification from selected sample locations which comes under indirect data source. For example, digital elevation model can be generated from topographic data such as spot heights or contours, etc., that are usually obtained by indirect measurements from, for example, from the Survey of India topographical sheets. So now we also discuss about how database can be organized in different ways, commonly known as the database models. The conventional database models are, first can be the good example, can be the relational model, where data are organized by records in relations with which may resemble as a table. You can see this in this slide where on the right side we are showing a picture where the network model data are organized by records which are classified into record types with pointers linking the associated records. Another can be the hierarchical model. So here in hierarchical model, data are organized by records on a parent-child that is one-to-many relations. Another can be the object-oriented, where data are uniquely identified as individual objects that are classified into object types or classes according to the characteristics. Characteristic means attributes and operations of the object. So just to summarize, spatial database may be organized as either object-based model or field-based model. In object-based databases, the spatial units are discrete objects, which can be obtained from field-based data by means of object recognition and, as I have mentioned earlier, as mathematical interpolation. In the object-based model, spatial data is mostly represented in the form of coordinates list. The good example is the vector lines, and generally called as the vector data model. When a spatial phenomena database is structured on the field-based model in the form of grid or squares or rectangular cells, then the representation is called as raster data model. So the geospatial database possesses two distinct components such as locations and attributes. So geographical features in the real world are very difficult to capture and may require large-scale database. And spatial information science can organize reality through these data models. Each model tends to fit certain types of data and application better than others. All spatial data models fall into two basic categories, as we are saying. They can be either raster or the vector.